Hello everyone, welcome to Computer Aided Analysis Laboratory. I am RAKESH VALASA. In this video lecture, I am going to explain how to solve the simply supported beam with uniformly varying load in ANSYS 19.2 mechanical APDL on Windows 10 platform. The objective of the experiment is to plot the shear force and bending moment diagrams of the given simply supported beam subjected to uniformly varying load and point load. The problem statement is plot the shear force and bending moment diagrams for the beam shown in figure. Assume rectangle cross section area of 0.2 meters into 0.3 meters. Young's modulus is 210 gigapascal, Poisson ratio 0.27. Here the Young's modulus is 210 gigapascal. Now convert into Newton per meter square. That is 210 into 10 power 9 Newton per meter square. Here the given diagram is uniformly varying load and point load. This total length is 3 plus 1.5 plus 1.5, that is 6 meters. Uniformly varying load element length is 3 meters. This uniformly varying load end point to this point load element length is 1.5 meters. This point load to end point, that length is 1.5 meters. So this problem having three elements. Element 1 is uniformly varying load, element 2 having no load, and element 3 also no load. But this entire problem having 4 nodes because it having 3 elements 1, 2, 3, and so it having 4 nodes. Let us see coordinates for node 1. This is the starting point. So let us take 0, 0. Second node having this distance from first node, that is 3 meters, y0, z0. So 3, 0. Node number 3 coordinates are this 3 plus 1.5, that is 4.5, 0. Node number 4 coordinates are this entire problem length, that means 3 plus 1.5 plus 1.5, this entire beam length 6 meters, 0. Let us see how to solve this problem in ANSYS 19.2 mechanical APDL software. Go to the start button, ANSYS 19.2. In that you have to choose mechanical APDL 19.2. Okay, when you click on this one, it is launching. It takes few seconds for launching the software. This is the graphical user interface of ANSYS 19.2 software. For any problem in ANSYS, you can follow 3 steps. Go to the utility menu, file, clear, and start new. Now you have to choose do not read file, then click on OK. Now click on it. The second step is file, change job name. Here the job name is simply supported beam with UVL. Simply supported beam with UVL. Then click on OK. The third step is file, click on change title. This here you can type shear force and bending moment diagrams. Shear force and bending moment diagrams. Bending moment diagrams. Then click on OK. These are the 3 steps common to all problems. Next, go to the main menu, preferences, structural, OK. Second step, preprocessor, element type, add or edit or delete. Now click on add. This problem is related to beam. Choose beam, 2 node 188, then click on OK. Now close this window. Next, go to the material properties, material models, structural, linear, elastic, isotropic. Enter the Young's modulus, that is 210 e power 9, 210 e 9, Poisson ratio 0.27. Then click on OK. Now close this window. Next go to the sections, beam, common sections. Here the cross sectional area is rectangle shape, so subtype you can choose square shape. Now enter the width is, here the width is 0.2 meters, height or depth is 0.3 meters. Now click on preview, then click on OK. This is the side view, so now change from this side view to front view. Next go to the modeling, create, nodes, inactive coordinate systems. Here the node number 1, first one having coordinate 0, 0, then click on apply. Second node coordinates are 3, 0, 3, 0, then click on apply. Node number 3 coordinates are 4.5, 0, then click on apply. Node number 4 coordinates are 6, 0, then click on OK. Okay, if you have any doubt, go to the plot, nodes, list nodes, coordinates only, then click on OK. You can see here node 1 coordinates 0, 0, node 2 coordinates 3, 0, node 3 coordinates 4.5, 0, node 4 coordinates 6, 0. Here the numbers are hide. You can, how to enable that numbers, go to the plot controls, numbering, node numbers, then click on OK. 1, 2, 3, 4 enabled. Next go to the elements. This entire beam having same material properties, so no need to choose element attributes. Then go to the auto number, throw nodes, pick node 1 and node 2, then click on apply. Next pick node number 2 and 3, then click on apply. Then pick node 3 and node 4, then click on OK. Now the elements are created. Next go to the loads. Now apply the loads. Analysis type, new analysis, static, OK. Define loads, apply, structural, displacement. Here the on nodes, here the node 1 and node 4 having supports are there, except rotational Z, remaining all are fixed, because this is the uniformly simply supported beam, rotation Y. Then click on OK. Here node number 3 having point load is there. Next go to the force or moment, on nodes, choose pick node 3, then click on apply. That load is acts in Y direction, so change from Fx to Fy. This value is minus 80 kilonewtons, minus 80 E3, that is acting in vertical direction, vertical downward direction, 80 kilonewtons. Then click on OK. Next one, from node 1 to node 2 having uniformly varying load, so choose pressure on beam. Now pick element in between node 1 and node 2, then click on apply. Here the load key 1 means it is a x direction, so uniform varying load acts in vertical direction, so change from 1 to 2. Here 2 means in vertical direction. Next, pressure value at node I. In the given problem, this is the starting point, this is the end point. In the starting point having that value 0, end point having 40 kilonewton per meters. First one is node I 0, node J 40 E3. Just enter the only value, no need to give the sign. E3, 40 E3, then click on OK. This is the uniformly varying load and point load. Now capture this image. Go to the report generator, append OK. Yes. Go to the plot elements. Now capture this image. This is the boundary conditions. Boundary conditions for boundary conditions for simply supported beam with uniformly varying load. Simply supported beam with uniformly varying load. Then click on OK. Next, go to the solution. Solution, solve current LS. Then click on OK. Now the solution is done. Now close this window. Next, go to the general post processor, plot results, deformed shape. You can choose deformed place, undeformed shape, then click on OK. Now you can capture this image. This is the deformed place, undeformed shape. Deformed place, undeformed shape. Undeformed shape. Then click on OK. Now you can see the animation. Go to the plot controls, animate, deform results. Here DF solution, US, UM, then click on OK. You can see the deformed shape visualization. Now stop this window, close this one. Next, go to the element table, define table. Now click on add. Okay, by sequence number SMISC comma 3. Now click on apply. Now scroll down, choose by sequence number. Next 6, apply. By sequence number 16, apply. Next by sequence number 19, then click on OK. Now close this window. Now see the list element table. Go to the list element table, choose these 4 values, then click on OK. Now note down these values in your LMRB. Here next, go to the plot results, contour plot, line element results. In the here 2 terms are there, bending moment and shear force. Here according to alphabets, B comes first, S comes later. So here 2 pairs are there. Here I am telling how to remember shear force values and bending momentum values. Here let us take 3, 6, 1 pair, 16, 19, 1 pair. Here the bending moment diagram, B comes first. So in the first pair, first one, second pair, first one, it gives the bending moment. So SMISC 3 and second pair, first one, it gives the bending moment diagram. Now capture this image. This is the bending moment diagram for the given problem. Bending moment diagram for the given problem. Next, line element results. For shear force, in the first pair, second one, in the second pair, second one, 6 and 19 give the shear force diagram. 6 and 19 give the shear force diagram. Now capture this image. This is the shear force diagram. Force diagram. Okay, this is the way to you can easily remember the pair of shear force and bending moment diagrams. 3 and 16 give the bending moment diagram. 6 and 90 give the shear force diagram. Now go to the HTML report assembler. Give the report heading. Here the title is shear force and bending moment diagrams. Shear force and bending moment diagrams. author name is type your name. Next subtitle is simply supported beam with UVL. Simply supported beam with uniformly varying load. Then click on OK. Now add the capture images. Then click on preview. Okay, due to compatible issue it is not opening. Just go to the folder, ANSYS 2024 simply supported beam with UVL report. Here open HTML file. Now click Ctrl P. Now convert into this PDF, Microsoft Print to PDF, then click on print. Now give the file name, save as type is PDF document and save in your specified drive, then click on save. Then share this file to your mail or WhatsApp, that is depending upon you. From that you can take the printout. Okay, this is the solution for the given problem. I hope this solution is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.